Okay, so we are doing 4.3, graphing equations in the form ax plus by is equal to c. Okay, so this form is also known as the standard form. So the standard form is when you have your variables on the left side of the equal sign and a number on the right side of the equal sign. All right. So make sure you recognize the difference of this form compared to what we have done in 4.2, which is the slope-intercept form. Okay. So the main difference again is that the slope-intercept form only has the variable on the left side of the equal sign. Look at this one. This is your slope-intercept form. Okay. Only the y is on the left side of the equal sign. Everything else is on the right. Okay, so that is called the slope-intercept. The standard form would have the x and the y on the left side of the equal sign, like this. All right. Sometimes the x and the y would have numbers, and that's okay. So, for example, 2x plus 10y equals 7. So that is a standard form. All right. It could be negative 3x plus 1/2 y equals 200. That is still the standard form. Once again, only the number is on the right side of the equal sign. Okay. Now the slope-intercept form is like this. The slope-intercept is y equals 7x minus 11, right? Only the y is on the left side of the equal sign, all right? Or y equals 2 minus 3x. Okay, that's still a slope-intercept form, although if you think about it, you have to switch this with this one, wherein what I'm saying is you have to put it this way so that it's really in slope-intercept form. Okay. All right. Let's look at what we have to do. So how do you graph a linear equation in standard form? All right. Well, if you think about slope-intercept, what we did with slope-intercept in 4.2 is we had to graph the intercept, the y-intercept, which is known as the point wherein your line crosses the y-axis. And then you would have to determine your slope, and then the slope will tell you how you're going to be finding the next point, and the slope will tell you whether to go up or down as you go to the right. Once you have established your second point, you connect the 2 points and you have a line. So how do you graph a linear equation in standard form this time? Ax plus by is equal to c. All right. This is your standard form. All right. Or an example would be this one. Okay. So how do they connect? Well, everything that has x and y is on the left side of the equal sign. Only the number is on the right side. You got it? So I wrote here a question. How many points do you need to draw a line? That's the basic question so that you will know, at least you have an idea of what to do as you are graphing. Well, how many points do you need to draw a line? All right. At the minimum, you need 2. All you need to have would be 2. For example, if I have a point here and a point here, all right, when I connect them, I have a line, right? So that's all you really need. You need 2 points. So to be able to graph this equation, I need to find 2 points. Now, there are so many ways to do this. As I always tell you, in math, especially in the lower grades, there's so many questions wherein it can be done in so many ways. It just depends on which one you are more comfortable with. Now, I will go by what the book has shown because I myself feel that this is the easiest way. All right. You need to find 2 points, and those 2 points would be the x and y intercept. Now, if you're thinking, why is that? Well, isn't it that if you have 2 points, you have enough to draw a line? So if you have your y-intercept, and I'm just saying, this is not even the y-intercept for the equation that we have. I'm just saying that let's say this is your y-intercept, and this is your x-intercept. So if you connect them, then you have a line. Isn't it that easy, right? So that's what I'm trying to tell you. So To find the x-intercept, what we need to do is to figure out, okay, if it's the if it's the x-intercept, that is the point where my line crosses the x-axis. So that means the y value is 0. Okay. For example, if my line crosses this point right here, that point is 0. All right. That is called the x-intercept because the line crosses the x-axis. The x value is 4 and the y is 0. All right. So that is an important concept of an intercept. Where the line crosses an axis, the intercept at that point, the for example, it's the x-intercept that you're looking for. It's the y value that is 0. All right. If it's the y-intercept that you're looking for, it's the x value that is 0. So going back, if we're looking for the x-intercept, that means we're going to be setting y equal to 0. All right. Meaning make y equal 0. All right. Now, what we have here, all right, what we have here is 2x plus y equals 6. All right, and if we make y equal 0, so that means you are going to replace y 0. We're going to solve for x. 2x equals 6. Remember one-step equations. Divide both sides by 2, and x is equal to 3. All right. What does that mean? So when y is 0, x is equal to 3. All right. So when y is 0, x equals 3. Or in terms of your input-output table, this is 3, 0. And those two will be your ordered pair. All right. Where is the point in your graph we're in? It's going to be, oh, ignore this. All right. This one. That's, I should have erased that. X is 3, y is 0. So I'm going to use a blue one for this. X is 3, y is 0 right here, somewhere here. All right, so there is your 3, 0. Now, the next thing for us to do is to find the y-intercept. And when it's the y-intercept that we're looking for, we will set x is equal to 0. All right. What does it mean? In the equation, 2x plus y equals 6, we are going to replace x with 0. So 2 times 0 plus y is 6. This cancels out. Y is 6. What does that mean? All right, so if x is 0, y is 6. In your input-output table, if x is 0, y is 6, and there are your coordinates. Okay, so where in your graph is 0, 6 going to be? And 0, 6 would be up here. All right, right here. Okay, so what do? We connect those 2 points. Okay, so and there is um, a simple sketch of the graph. All right, it's not a perfect one. I'm just saying that that is almost like well, that's going to be a good graph for 2x plus y equals 6. Okay. All right, so I'm going to go over questions that are similar to the homework that I'm going to give. Okay. Okay, so here we go. I'll start with 4.3, determining whether the given ordered pair is a solution. Okay. Now, we have seen questions like this before. I'm going to be doing number 1. So this is page 137, all right? Number 1A. So you are given an ordered pair, 2, 3. Is it a solution to, is it a solution to 3x minus 5y equals negative 9? So how do you figure out if an ordered pair is a solution to an equation? I think we did this also in 4.2. If you will recall, what you're going to do is you're going to plug in the values for x and y, and then you're going to determine whether it is a true statement, meaning the left of the equal sign with the value of the left side of the equal sign will have the same value as the right side. So your ordered pair would be made up of your x and y values. Okay. So your value for x is 2, your value for y is 3. So what are you going to do? You're going to replace the x and y with those two values. So 3 times 2. Where did the 2 come from? That is the x value in the ordered pair given. Minus 5 times, what is the y value? 3. Where did that come from? That is the y value given in the ordered pair. All right. And then we're going to see whether this is going to be equal to negative 9. And we're going to put this question mark because we're not sure. Okay. 3 times 2 is 6 minus 15. Is that going to be negative 9? And since the left side is the same as the right side, therefore it checks out. Therefore, 2, 3 is a solution. Okay. All right. Number 2. Number 2. 2a. Okay. Now it says graph the equations using the table provided. So an equation is 2x plus 3y equals 6. Okay, and then there's a table given wherein it says xy, and then x is 0, and then no y, then y is 0, and then no x, and then x is negative 3. So what it is saying is you are going to be figuring out values that would go for, that would complete each ordered pair, all right? Okay. So let's see if I can just have a quick um, xy plane here, all right? So more or less something like that, okay. All right, so let's start. So if x is 0, you're going to be plugging in that x into here, all right? Okay, you're going to replace the x with a 0, all right? Why am I using a 0? Because that's what it says here. We are going to figure out what value we need for the y here, all right? So if x is 0, 2 times 0 is 0, all right? So ask yourself, 2 times 0 is 0. That leaves you with 3y equals 6. Therefore, y is 2. Isn't it? Okay. So that means in here, y is 2. Oops. All right, so this is 2. Now, if y is 0, what is x? So we're going to need another point, all right? Now, if y is 0, that means this becomes 2 times 0 becomes 0, isn't it? So that leaves you with only 2x equals 6, or x equals 3. So this here is a 3. All right. So I think we have enough to graph the points now. What is y going to be when x is negative 3? I leave that for you to do. But really, you don't need a third point because we have enough. Okay. Okay, so if this is 2, this is 4, this is 2, this is 4. All right, so where is 0, 2? All right, so where is 0, 2 going to be? 0, 2 would be 0 on the x, y is 2 right here. Where is 3, 0? That is x has a value of 3, y is 0 right here. All right. And then we're going to be connecting those two. Sort of like this. Okay. Again, it's not a perfect graph, but more or less that is how it's going to look like. All right, so that is number 2A. I will do another one. Number 3A. Okay, number 3A is just like what they have discussed on page 136, horizontal or vertical equations. Okay. 3A. Okay. You will graph x equals 3. The equation is x equals 3. So how does that look like? So guys, whenever it's just an x, there is no y. Okay, this is what you are going to do. One, one, two, three, three, four, five. All right. One, two, four. All right. This is one, two. Man. Okay. One, two, three, four, five. All right, guys, just to speed this up, it's taking too much time to be able to put in the numbers. But when you graph, please make sure you put in all the numbers, okay? So, excuse me. What I'm saying is, if your equation only looks like this, x equals 3, there's no y variable. Right away, it is going to be a vertical line. Okay, vertical line, and that line will be passing through the point 3, 0 on the x here. All right. So really what you can do is find the number 3 on the x and then draw a straight line through that. Okay, like this. And there's your graph. Now, if you're thinking, well, why is it like that? Why is it a vertical line? Because really, if you think about it, what's going to happen is if you are going to create an input-output table for it, x, okay, x, y, all right, and we're looking at ordered pairs that we're going to graph. It already tells you that your x is going to be a 3, all right? Your y value can be anything. Your y value can be a 0. The x is going to be 3. Your x value is going to be 3. Your y value can be negative 4. Your x value is going to be 3. Your y value can be 7. All right. What it is saying is, if you look at your graph right here, it will pass through all of those ordered pairs. It passes through 3, 0, right? Which is this one. That's 3, 0. It passes through 3, negative 4, right? Which is probably this one. It passes through 3, 7, which is probably this one, all right? So once again, the concept here is if you are graphing an equation wherein only the x is there, there's no y, right away it is going to be a vertical line. That's all you're going to have. All right, next one. I'm going to be doing letter B. All right, let's just use the same one. Okay, okay, letter B. Okay. The graph is going to be y equals 3. Okay, I'm going to be using blue for this. So as you can see, there is no x, it's just the y. Okay, what does it mean? I think you already get the idea. This time it's going to be a horizontal line, wherein it will pass through this number on the y. Okay, so find 3 on the y right here. Okay, so what's going to happen is I'm going to be graphing this using blue. Okay, going to have a point here, 1, 3, then I'm going to make a line pass through it. And that's about it. All right. There you go. All right. Now, if you're thinking, okay, once again, why is it a horizontal line this time? Because if you are going to create an input-output table, wherever it is that you will have an ordered pair, it will always be a 3 for the y. So for example, if y is 3 and your x is 0, where's that going to be? Right here. Okay. If your x is 1, y is 3, this one, where is it going to be? Right here. If x is -2, y is 3, where's that going to be? Right here. So just like what happened in the previous example, um, it's just going to be giving you a straight a line wherein it is going to pass through the y value. So in summary, if you're graphing a line or an equation wherein you only have the x, there's no y. Like here, x is equal to 3, you are going to have a vertical line. It passes through the number 3 on the x-axis. Okay. While if you only have the y and no x, like in letter B, y is equal to 3, you are only going to have a horizontal line passing through the number 3. All right. And I think that's about it for me for this section. And I'm going to be, uh, are there any more? Okay. Okay. So use the graphs to complete the tables. I have two more. I forgot. Sorry. So for number 4, it says use the graphs to complete the table. Okay. So it says here there's an x and a y. Okay. -2, -1, 0, 1, 2. All right. So I'll just give you an idea of how to do this. Okay. And then I would want you to do the rest. What's the y-intercept in the graph? And I don't have it right here, but I want you to be able to look at the picture. The y-intercept in your graph, this is page 140. All right, page 140. This is letter A. All right. But the y-intercept is 0, 1. Okay. The y-intercept is 0, 1. Right here. This is the y-intercept. Y-intercept. I hope you see that. Now, ask yourself, hmm, what is that point in the graph wherein the x value is 1? So I'm looking for that point in the graph wherein the x value is 1. Okay. But the y value would have been a 2, right? 2. Now I'm doing this on purpose wherein I'm not showing all of the points and all of the numbers because I also want you to attempt to solve this yourself. Okay. I already gave you 2 numbers, 2 values. I want you to do the rest of it. Okay. Now with number 5, sketch a graph of a linear equation parallel to the given equation that passes through the point indicated. Okay. All I'm going to tell you is if you are graphing a a line, all right, which would be parallel to another line, that means they will not intersect. What does parallel mean? Two lines that don't intersect. All right. So that means that if two lines will not intersect, this is actually a math 10 concept. They have the same slope. So I'll leave it at that and I will let you think about how you can solve that. All right. Anyway, the answer key is at the back, so just try it, okay? And then we'll see what happens. And I think that's it for me for this video. All right, until next time. Thanks, bye.